Hello students, welcome to the first video of this new playlist. In this playlist, I will upload solution video of each of the questions from one of the most recent past paper of further pure mathematics, which is the May 2024 FP1 paper. So since this is the first video of this playlist, so in this video we will be solving the first question of this paper. So let's get started with the first question of the paper. Okay, number one, part one. Here the question says the matrix A is defined by A equals to 3k 4k minus 1 to 6. Okay, where k is a constant. So part A of 1, it's asking to determine the value of k for which A is singular. Okay, so we know that a matrix is singular when the determinant of the matrix is 0, right? So we will consider that concept in this case. Okay, so for part 1a, determinant, at first let's figure out the determinant of A. Determinant of A, it's basically AD minus BC. Okay, so what is A, what is B, what is C, and what is D? Basically, this is A, this is B, this is C, and that one is D. So AD is basically 6 times 3k. That would give you, okay, let me write it down, 6 times 3k minus BC. B is basically 2, so 2 times 4k minus 1. So negative 2 times 4k minus 1. Now to get the determinant of A, you just multiply out the brackets and then add them up. So you will get 18k negative 8k plus 2. Okay, so determinant of A equals to 10k plus 2. Okay, so since the matrix, we have to consider the value of k such that the given matrix is singular. So determinant of A would be equal to 0. Okay, so now equate the determinant, which is 10k plus 2 equals to 0. So take 2 to the right side, so you will get negative 2. So negative 2 over 10, that would give you negative 1 over 5. So this is the value of k for which the given matrix will be singular. Fine. Okay, next is part B of 1. Okay, here the question says given that A is non-singular. Okay, A is non-singular. So if A is non-singular, then definitely it will have an inverse matrix. Okay, so part B is asking to determine that inverse matrix of A in terms of k, giving you an answer in simplest form. Okay, so we need to figure out the inverse of the given matrix. So the given matrix, it's in the form of A, B, C, D, right? Okay. Now we already know the determinant. The determinant is 2 plus 10k. So to get the inverse matrix, we know that inverse matrix it is equals to 1 over determinant of A times, we have to consider the position of A, B, C, D. So the position of A and D will get interchanged. So D will be on the top left corner and A will get to the bottom right corner. Okay, DA, and the other remaining two, B and C, their magnitude will become negative. That's it. So this will be negative B and that will be negative C. Okay, so determinant of A, this is 1 over 10k plus 2, 10k plus 2, and then the position of D. Okay, D was 6, so 6 will be there, and A was 3k, so 3k will be here. Okay, so B, okay, 3k is there, so B was 2, but now it will be negative B, so that is negative 2. And at last C, it will become negative C, so negative C is basically negative 4k plus 1, so that would become 1 minus 4k. That's it. So this is basically the inverse matrix of A, and that's what part B of 1 has asked to determine. Fine. Okay, next is part 2. In part 2, the question says the matrix B. This is another matrix. Matrix B is defined by B P0 0Q. Okay. So where P and Q are integers, state the value of P and the value of Q when B represents. So part A, it is in A, they are asking it represents an enlargement about the origin with scale factor -2. An enlargement about the origin with scale factor -2. Okay. So to understand this matrix, the transformation matrix, you have to consider the unit matrix. So unit matrix is basically 1, 0, 0, 1. This is the unit matrix. So this is also called as identity matrix. Okay. So this is identity matrix. Okay. So we will consider the transformation of this matrix. Basically, scale an enlargement about the origin with scale factor 2, -2. So that means if you consider the x-axis and the y-axis, that would make you understand more clear about it. Let's consider. Look, this is the y-axis and this is the x-axis. So basically, the identity matrix or the unit matrix, there is 1, 0. It represents this 1, 0 represents a point. There is 1, 0. 1 is the x coordinate of the point on the x-axis, and this is the y coordinate. So this is 1, 0. Okay, this is 1, 0, and 0, 1. We have 1, 0, 0, 1 in the identity matrix. So the second column, it is basically the coordinates of a point that lies on the y-axis. This is 0, 1. Okay, so we will consider this enlargement by scale factor -2. That means here in this case the x coordinate will get multiplied by -2. It will come here. Okay, to become negative. It will become -2, 0. So it will get to there, right? So this will be -2, 0. Okay, and this point, the point on the y-axis, it will become 0, -2. So it will come here, which is 0, -2. So that means the matrix, given matrix B, it is basically in the form of P0, 0, Q, right? So that means for part 2A, the value for P would be -2, because we could see that the identity matrix, the first column and the second column, the identity matrix, it is getting to -2, 0. It is becoming -2, 0 and 0, -2. So due to this enlargement, the identity matrix is getting to -2, 0, 0, -2. So that's why the value of P is -2. The value of Q, it is also -2. That's it. That's the answer for part A of 2. Fine. Okay, next is part B from part 2. So here the question is asking to state the value of P and the value of Q, which B represents a reflection in the y-axis. Okay, a reflection on the y-axis. Look at the sketch, a separate sketch. A reflection on the y-axis. Okay, so the identity matrix, it is 1, 0, 0, 1. So this is 1, 0, and this is basically 0, 1. Okay, so reflection on the y-axis. So if it is reflected on the y-axis, this 1, 0 will come here. So due to this reflection, 1, 0, 0, 1, the identity matrix will become -1, 0, -1, 0, and the point on the y-axis, that is 0, 1, it will remain as it is. 0 1. So that means in place of p we will have -1, in place of p we will have -1, and in place of q we will have 1. That means the value for p it is -1, and the value of q is basically 1. That's it. That's the value for p and q. Fine.